Hello everyone, good evening and thanks for joining our session. And today's session is to be taken by Anant and Anshul. And the topics which are to be
Dude,
covered in
it's
today's.
Anshul and Anirudh.
Okay, Anshul and Anirudh, I'm sorry, my mistake. And the topics that is to be covered by them is put up on the PPT, and please kindly follow the instructions given in the PPT. I hope all the participants read the instructions and the session would be taken over by the speakers.
Thank you, Madan. So for today's session, we are going to be discussing about game physics and how to apply that in React 3 Fiber, which was a reconciler for Three.js. So we will be continuing from where we left in the last session. So starting off, I have documented everything in the workshop repository. So you can go through it. If you want to install the React app and add the dependency, you can do that. I have added the command. Or else you can just clone this repository and just start it and edit it out code itself. All the concepts which we are going to be discussing are here. Some React basic which are like soul of this whole thing is state, hooks, and props. We discussed it in previous webinar. So for today, our main topic is physics, how to apply that in 3D models to make our canvas more realistic. So what physics library we are going to be using is Canon.js. Yeah, so let's go. Canon.js. Canon.js is a physics engine for web browsers. Let me just go down here. These are examples. You can actually check them. I have given the link of. I have provided the link here. So yeah, it's inspired by Three.js and Mojs, and it's a physics engine for web browsers, as I said. So what is Mojs? Mojs is a bullet physics engine. So when two 3D shapes collide, if there's no physics in them, they will just pass through each other. But if we apply physics to them, the collision will take place, and all the physics concept and theories will apply to them. So that's what Mojs does. It's just for collision. So Three.js and Mojs and other features of physics, other laws as well, and you combine them and you get Canon.js. So why we are using Canon.js? Because it is lightweight, smaller file sizes are there, and it is compatible with most of the browsers. And it's open source, and it uses a Gauss Seidel solver. It's faster than other physics engine because it creates an array and then solves all the constraints. So on the website only you can go to the documentation, all the physics concept, body, any shapes also, everything is here. You can just click on them and the properties and all that will appear here. What all the methods you can use, parameters and everything. So this was Canon.js. Um, Same for Mojs also. How can you use it? How can you write Mojs and how can you integrate it with your JavaScript application? Everything I've documented here and provided the link. Uh, then what we are not going to be using this library or this repository, whatever you say. We will use reconciler for these. It's called Use Canon. Use Canon is a physics-based hook for React 3 Fiber. Because Canon.js is a plain physics library, so you will be coding in vanilla JS, and in React it will be hectic job to do. We want to make our code less lengthy, so that's why we prefer this Use Canon. And Use Canon is built by the same organization which created React 3 Fiber, and also the same guy Paul Henschel. So this or PMNDRS, this organization has very high, what do you say, very high quality of repositories, which you can use for your projects. And all. So when we will code, you will know how to use Canon. So I guess let's start for it. I have a basic code here. As discussed last time, we created a box. This time it's a sphere. Right now, in the code, you can see I have created a functional component of sphere, And in return I have mesh, which has buffer sphere buffer geometry and mesh basic material. And this sphere is not proper sphere. And why is that? uh, by default you get a sphere whose width segment and height segment is about 12. So you get this kind of sphere. But as you increase the argument to 32 height and width, you get a perfect sphere. So we are going to be doing same. First argument is a radius, then height segment, then width segment. So if I save it, yeah, we get a perfect sphere. Right now it's small in size because I have decreased the radius to half. Uh, now what we need to do, this all these things were discussed earlier. I have imported the sphere component here. The camera position I have set, and FOV as discussed earlier in the previous session. Field of view. People who have ever done photography, they know about field of view. So I've set the field of view. Now what I need to apply physics to it. So uh, in real world, whenever a object is in space, it will fall because of gravity. If we throw the object up, it will fall because of gravity. So we need to apply gravity to it. So how can we do that? So there's in we are going to be using use canon library, and there's something called use sphere. So as I said, it's a physics hook library. So what all there was in Canon.js, it just made it more simpler by making it hooks. You can go through what hooks are. We discussed in the previous webinar, so I'm not going to go there again. But you can go through hooks in React.js documentation. So also, yeah, first to apply if when you're coding this all the 3D objects, you need to apply physics to some of them. Some you don't need to apply. So there's something called physics. It's a use canon tag. So what all shape you need to apply physics to, you need to encapsulate between physics tag. Okay, now we can. So the general convention of using use sphere is we need to provide a reference variable for that hook and use. So the use sphere will take a function which will uh, which will have arguments. So when you apply physics to any object or any plane or whatever kind of buffer object, so we need to specify all the arguments, position, its mass in the use sphere only. It won't be controlled by the mesh as provided given earlier. So you need to specify it here. I will just remove it from here. Even if it says not problem. Uh, so now argument is done. We need to give it mass. Without mass, the object will keep floating. Okay. Still, it's not falling. And why is that? Because we haven't applied gravity yet. So physics tag has a property called gravity. Gravity takes array of coordinates. So if I do, oh yeah, I haven't added trust here. Yeah, so the object is falling in minus in x on x-axis in minus 10. Okay, this is actually here it is not actually coordinate. It is the intensity of gravity in that direction. So if I do minus 10 here too, it will start to move diagonally like this. So I want it to fall down. And let's increase its speed. Yeah. So we have applied gravity. The object is falling, and now we need something to stop that object from falling, like a board or something, so that we can show collision. So I will just create another component. Let's name it something. Gosh. We'll just take so I need not exactly a cube. I need a rectangle. So I'll change the color. Round for Yeah, so right now it's not actually, the object is passing through this cuboid, as you can see. This is because we haven't applied the use box hook here. So if it doesn't matter if you put your object within physics, if you aren't using any shape hook here, you can't actually make the object actual physics object. So we will do that. The writing convention is again same. And it will take argument again. So whatever is written here. Okay, so uh, and always remember to reference it to the mess. Uh, Still, it's not happening because the position of this object is actually above the sphere. So we need to set the position below. So there's something called API. Uh, thing about API is API is like any other API. There's what general API is. Uh, Software architecture is already there. You link that thing to your application, and it pulls data. Uh, it pulls data from there. It throws your function data from there and return your the process data. Same thing is here. So, the function of API here is whatever we are going to do with the box, we need to specify it with APIs. Let's code and see how this. I will just code, then we will discuss what we did. Okay, and there there's something called default contact material. We need to specify the contact surface. So in the physics tag only, we need to define our contact surface here. Mustache pocket and restitution. I guess everyone knows about what restitution is. Coefficient of restitution in this school we have learned. Okay, what isn't working? Okay, cache is there. Fuse box. Fluid mass. We need ball should. Okay, we need. We can actually do this. Um, Always sphere. Okay. We can apply API here too, and use the frame. We need to bring in another hook called viewport. So in the last webinar we discussed what viewport is. Whatever the area visible here is actually viewport, and now we can specific do similar this thing to see dash. You can specify the material. Standard material. Okay, as we see, then we will need lights. Yeah, so you actually, if you look closely, you can see there's black object because we have declared standard material, so we will need lights. So let's bring in lights. Similarly, we will need point light. And remember, for point light, we need to specify the position. So again, we are going to be making a strip light out of it. So, strip light is nothing but point lights in opposite direction. 2 points light facing each other. Yeah, perfect. Now let's go back to our dash here. Mm, Uh, okay, so there's something called state, and state basically is the state of your whole thing, and how we're going to be using that is we will be declare because we want to make this application responsive. So if we declare the size as points here, as decimal points here, so it won't be responsive because every viewport has different size. So we need to mention it according viewport. So state dot viewport and height divided by 2. So whatever the height of viewport is divided by 2. So yeah, it's just centered. 3 will bring it a little bit above. Yeah, that's working with its position. And same for this we can do. Just give me a moment here. Yeah, for this we can actually do this that it moves with the block moves with our mouse pointer. So state dot mouse dot x, and let's see. So, yeah, the object is moving and physics is there. So now what we need to make some like more hurdles out of it. APIs here. We can, in the box only, we can do this. Rotation dot set. What we want to do is, as this dash reaches the end of the walls, it should make a curve, make an arc. So we will need angles to do that. Uh, so and this arc should be around the z-axis because it's coming straight out of, so the arc should be about that axis. So we will declare 0 0 here, and same thing here. We will do state dot viewport dot x and into the angle how much we want to move it. So math dot phi. Uh, Whenever we are coding in React 3 Fiber, we will always, for angle, we will always use mat.py. It gives us 180 degree. Now we can divide it and get our desired angle. Multiply it. Okay. Perfect. Wow. 1 minute. I will just refactor the code. Should do. Yeah, so I need to do this. And now coming to our sphere. So now the sphere is, yeah, you can see the rotation here with mouse pointer. It's actually rotating. So what we do want to do here is we want to, because ball is falling, and whenever it falls, we want it to reload to its original position. What general idea here is we want to create a plane there, and whenever the sphere collides with that plane, it should roll back to its origin position. So generally, if we use normal React 3 Fiber, we might have to create a plane and then add a function on collide and all that. But when we are using use canon, we have a hook called use plane, which we don't even need to like create a component plane. We can just create in sphere only. We can just use that hook directly, and we will have a plane. So let's do this. And we need to specify the position of the plane. So it will take an array. We have already called viewport here, so we can just specify its dimension by viewport. Um, and there's another thing we need to. In last webinar, we created a plane. So by default, plane comes parallel to the y-axis. In xy plane, we need to move the plane to the xz plane. So we will rotate it by minus 90 degree. So to do that, uh, we need to again do same thing as we did in last webinar, and 180 degree minus 180 degree divided by 2 and 0 and 0. And we have a rotation here. But we need that when sphere collides with this plane, it should revert back to its original position. So it already has a property called on collide. So on collide will take a function. This is ES6 kind of syntax, and we have already declared API in the sphere here. We will use that API because now we are setting the position and velocity of the sphere. So we need API. Guys, title. I written the wrong spelling, I guess. Yeah. So now it should work. Okay. So what else is there to do? So okay, fine. We need to create hurdles. Say more hurdles for this ball. Then we can do the surface thing. So for creating hurdles, we will just copy the same uh, this dash here. And this, we will remove this. Yeah, everything is fine. All we need to call all is here and color. So here we can actually give in, we don't need to write the whole thing here, and we can just give in props. Here too, we'll just write args here, and it will take argument from here, and here also we will just write color. So everything is set, and we can call in our, and they can take the position. So for position, we need to make it above in the viewport only by it's all your choice actually. So which okay, 2.5 0 and any color of your choice. And I will change the color of this and position to push it in opposite direction. Change the color to green. Yeah, so we got our boxes here, and we have our gravity, we have our default contact material. Uh, we can add color management for better. Yeah, so we just need to make the contact surface responsive to it. Uh, physics, sphere is there. Okay, let's go to the sphere. We have everything. And we have to this. Yeah, so it's now working. So we got our physics, and as the ball is falling, it's coming back to its origin position. So it's kind of like a, what you say, a very poor pinball type kind of game. So yeah, so what else we can do? We can make these hurdles rotate for more complexity or move. So let's get started with rotation. Mm, yeah, the hurdles. Yeah. So for rotation, we will need a lot of arguments, a lot of properties. So I will just try to keep it brief and explain all. So first of all, I will just note down what all variables I will be needing. So we need a variable for random number. Okay, let's call it R. Then we need a variable for rotational speed. Uh, yes, we need a variable to initialize something like initialize with 0 and then keep on adding the rotational speed to it. So the hurdles will keep rotating. Okay, what else we need? We need a boolean of rotation. So let's call it right. We're going to be trying to rotate it from the right side, and it's a boolean. Okay, and yeah, we need to another thing, we need to call width from viewport. So viewport's width we need to call. Yeah, so let's get started with this. So first thing first, uh, let's bring let's bring in viewport, and one viewport we need to bring with, and yeah, now we need to declare our variables. So uh, there's some other arguments which can be passed in the parameters, which is speed. We can declare the speed to 0.1, and what else? Yeah, the boolean. We need to declare the boolean here. Right is equal to false. Yeah, let's get to our variable. So first variable is the random number. Let r equal to math has a property called random, and rotational speed now. So let s be, we need to decrease the speed. 0.1 is a very high speed. I showed the rotation in the previous webinar. So we did 0.01 there for a smooth rotation. So and, we need to like multiply it with some decimal number, and then we have our value to initialize 0. Okay, and now we will be using use frame. Uh, in last webinar, I told you like in use frame you need to put minimum and efficient amount of functionalities only, because it renders 60 times in a minute. So so it sends data per second. So if you put anything heavy or any big animation, it will crash your app. So just keep attention to that. And then we got our, we have API of usebox. We're going to be using that. So API dot rotation, and here we need to write logic like how we want our the objects to rotate. So what logic could be there? So let's just, and in z axis, around z axis, I want this both the pedals to rotate. So so I will just multiply the random number with the angle 180 degree and add it. So now we need to specify the rotational direction. So here I'm going to be using a ternary operator, and rotation we have speed, same thing here but with negative sign. So yeah, that should do. Also, yeah, that will do, I guess. Yeah. So now our hurdles are rotating, right? Uh, and it, they will contact. Similarly, for moving these objects, you need to like bypass a lot of props and declare like what height and all these hurdles should be moving. So for the it will take a lot of time for to code that part, because you need to specify in another file all the like parameters and call it with a loop, like pass all the arguments with a loop. Uh, for a single, we can do it by there's some in the properties only. There's something called y. So you can specify y here. What y does is y will just specify on y-axis what its direction should be. It will just specify that. So this was about physics. We can do a lot more to make this more interactive. But for this session, I'm just keep it like here. I can show you an example. Uh, in the previous workshop directory, I just had it for next session, where I got this idea for. So someone actually created this game. It's just it's actually much more complex than what we did, but yeah, the base of it is same. So yeah, so you got an idea actually what you can do with this. So now coming to the second part of this webinar, the Gltf loaders. So like here, we only got a sphere, a rectangle or a square, and we can call circles squares and similar shapes. Even in die, if we use the helper library die, we can call in some triangles, some polygons and cylinders and all that. But what if we need like a proper object, like something like a building or a car or a tree? So how can we do that? So this React Fiber provides us with Gltf Loader. It's actually the same Gldf Loader which Three.js have. Let me just go back to the documentation. Yeah, Gldf Loader. So it's the same Gldf Loader. It's a GL transmission format. So what is that? What it does we can create any object, a car, a tree, or whatever. We can create in any animation software like Blender or Maya or anything, and we can export it in the GLTF format, and then we can import it in our code. So now Anirudh will show you how you can uh, create a GLTF object through Blender. Anirudh, you can take over now.
Hello? Hello? So am I
Yes,
Yeah,
Anirudh, we
audible?
you're
can hear you.
audible, Anirudh.
Yeah.
Okay. So now we are going to start with the Blender part. So I guess my screen is visible. So as Anshul shared that using Blender we can make complex shapes and export it in .glt format. So like we open Blender, like first I will try to correlate with all the physics that he explained just now. So here's Blender. Okay, navigation I'll repeat. I guess this middle mouse, hold middle mouse to like rotate, shift middle mouse to span, and that much only is required. So now we don't need this cube. I'll just explain with the sphere. So to delete, press X, and to add an object, go to add, mesh, and sphere. Like Anshul said that if you want to make it smooth, you have to make the number of subdivisions more. So I'll make it like 4 is enough, I suppose. So here this is very easy, like you can directly make here, then export in that website and use by using Gldf Loader. So you don't have to go through all the coding process, just import the model and use it. So here I have a like sphere, and like for collision part, I'll explain, like if I click on the sphere and press G to grab it, I can rotate it, press, okay, so Z axis to move it up. So it will go slightly up. So now I'm going to add a plane here just to explain the collision part and scale it. Press S and scale it up. So you got a plane here and a sphere here. So now here in the bottom you got an animation tab. So if you click on this, it will start animating. As you see, nothing is happening because all are static model, they are not moving. So convert into and apply physics on this. So we go here. Uh, there's a tab called physics properties. Click on that, you'll get so many, like we can convert into cloth, dynamic paint, soft body, fluid, rigid body, force filter, rigid body constant. So for this I'm going to set rigid body, click. So it will automatically apply all the properties. So here you see mass. So Anshul used, I don't know, so I'm using 1 kg of mass, is good. And here that this part is main type. So it is active. So what happens in active, like if I play, it will keep falling down. So that means the gravity has been applied, but the gravity by default will be like this on the negative y z axis. This is the bottom is the negative z axis. Here you can see positive z, positive y, positive x. So it keeps falling down. So to apply collision, I'll select this plane, go to rigid body again, and change it to passive. So active means the rigid body is active. Passive means it's not active. It will be a static model, but it won't. Okay, you see what happens. So it collides. So it is a rigid body, but it's passive, means its movement cannot be changed by any other force. So that is one way. So this was like what he explained. And so there you might have seen positions of each element. So like if I go to the sphere, scroll to zoom in and out, select the sphere, and here you'll get coordinates 0 0. Now the z is some 4.7. If I change the z like this, clicking and dragging, it will change. Same thing was applied in this code that Anshul taught. So same rotation is there, scale on one part, other, something like this. Control Z to undo. So now we are going to start with the main part. Last session, Anurag, we had told that it would be better if we, okay, what happened? Sorry, if we can use this Gltf in our Hack Club website. So me and Anshul got an idea that we can make the Hack Club logo, the existing logo, in the 3D models. So for that, I have an SVG file. So let me show you in Adobe Illustrator. So, yeah. Also in this also you can see. So I have only exported this white part. So I have the SVG file here. So these are Adobe Illustrator. All the files will be in SVG. .svg means scalable vector graphics. You can scale it as much as you want, but it won't lose its quality. Means like in photo in Instagram, if you zoom it or zoom out, it will become pixels, right? So here you can mm, zoom it as much as you want. It won't lose its property. So I have the SVG file here. So it is white actually, because the color, see the logo H, this part is white. So if I change it to any the other color and export, then it will be black or whatever color I exported. So the file is here. So I'm gonna import in Blender. So how do we do that is we go to file, import. There will be scalable vector graphics .svg file. So click on that and navigate to the folder. It was in downloads, SVG file, asset1.svg. So cool. I got my .svg file here. So it will be in curves. Like in Blender, there's a topic called curves. Like in Photoshop, there's paths. Here will be curves. So it will be made in this. Like if I click on this and go to edit mode, you can see this part. This are curves. If I move this, it will change its properties. Similarly, this part and this part. So I'm gonna work with only this for now. So I'm gonna delete it. The rest of Hack Club NMIT. Okay, the whole thing got deleted. So only delete this part. Press X to delete or del for delete or delete key. So now we select this object and go to tab. Um, because and hit tab to change to edit mode. Now I'm gonna position it, like press A to select all the curves points, and like use this key, move tool, and click this arrow to move it here. So you got it in center, right? So now scale it up. Okay, it's the world is very big, so this one doesn't look good. So I scaled it up, but it's still in the curves part. We want to convert into mesh. So what a mesh that Anshul told we go to add mesh and cube or circle. We get this thing, right? So we want to convert into this. So again, much more cube. So this is a mesh. When you go to edit mode, selecting a mesh, you'll get all different points: vertex, edges, spaces. So like all this. So now for now, this part is curves. So now I'm gonna convert into mesh. Simple. Click on it, right click, convert to mesh. So it will be converted into mesh. So now when we go to edit mode, we won't see those paths here. Now this will be vertices. So uh, as if you have good experience with 3D objects, you can see this model is messed up, like so many vertices, so many things are there, like kach means one point and here. So to reduce that, one thing we can do, you can select all this, right click, merge vertices at center. So it will reduce the number of points you need. For now we don't need because it's a simple model. So we are gonna use it as it is. So it is a mesh now. Now I'm going to add like a little bit. Okay, later we can add. So I'm gonna hit tab, press A to select all the faces and vertices. Go to extrude. If you remember from last, what extrude does is if I have a plane, so here's the plane. I go to edit mode and extrude a region. So it will extrude on along that face. Suppose this was okay. Now I have got a cube. So okay, so now all the faces are selected. If I do it, it will do something like this. So I select this. Okay, go to face select mode and select this face and click to extend. Or else, like you can do without using the extrude keyword. Select the space, your normal move tool, and press E to it will extrude along that axis. It's simple enough. So I'm going to delete this object. Okay. I'll select this logo, go to edit mode, A to select all, press E to extrude it. You see, it's very simple. So we got our Hack Club logo. Now the black color doesn't suit it much, so I'm gonna add black material, I guess. So I'll go to texture paint mode, because in Gltf, when you I'll tell you later. So no textures it says. That's why whenever an object doesn't have any textures, it will show you purple. So means there's a fault with the texture. So I'm gonna click on plus, add a texture, paints now, and I'll go to base color. So base color now it's black. So I'll change the color to like white will be good, and press OK. So now you see our model is so loading. This is rendered. I was in solid mode, this wireframe mode, the rendered mode, material preview. Like these are different modes to see different the object in different perspective. Like for when you are editing an object, you don't need the color, so you can work in solid mode. But and wireframe mode, like if you want to access this vertex or any other vertex, that type. Okay, so I will go to a material preview is means it will give information on the object with some fake lighting that you might have. So that's enough, I guess. So I'll go to normal. This is the normal means it's a rendered view. Like what will the object look like after rendering. So this is the rendered mode. So I'm gonna rotate this object. So I'll go like, so let's see the axis. This red line is x-axis, green line is y-axis, and blue line, there's no blue line, but it is z-axis. So I'll go to the transform properties and rotate in the x-axis. Click on the 90 degrees. Okay, so this rotate in x 90 degrees. Or else we can do one more thing. Select this object, press R, X, 90. Same thing it does. So the rotate is up, so means the object is up, and it's fine, I guess. So now what Anshul will show you is you have to place the lights. So you see this object is a light. So if I select and press G and move it, so the lighting of the object changes. So this light also has, every object has a coordinate. So here you will get a coordinates, X, Y, Z, rotation, scale, everything you'll get here. So this was like, if you wanna try make this Hack Club logo from scratch in the scripting file like Anshul did, it will be a lot of hectic job, and I don't think it is like possible. I think it is possible. So it will be a lot of hectic job. So if you want to see the Hack Club logo clearly, so I have applied a white color, so you can also color it in different colors, like shading or color, texture. Um, so this color, I guess you can change it to different colors, like green, I suppose. Let's change it to green. I prefer white for now. Gold color, I change some. So this is enough, I guess. Now I'm gonna export this object. Okay. First, if you see the lighting, I duplicate the light by pressing Shift D. You see, you'll be able to see the whole Hack Club. Okay, so I did slide, I don't need. Okay, so final thing is this: when you want to export this object, yes, it is very simple. Like file, export, and you will get gltf.2.0 dot this gltf file keyword. When you see, just click on this. Okay, so now where you want to export, I'm going to export in desktop and create new directory and name it Hack Club Gldf. It's fine. So I'll go into this folder. So now format will be gltf binary.glb file. One is gltf embedded.gltf, and this is .gltf separate. That will be .gltf plus .bin plus textures. So we need the textures, or else it will look colorless and it will look, it's very bad, means something not what you want to use somewhere. So that is this, and include, don't need to worry about for this time. Transform, no. Okay, geometry, you make sure this are selected, apply modifiers. For this I don't need apply modifier because I haven't used any modifiers here. Okay, UVs, normals, vectors, materials should be checked. Animation doesn't require because we haven't animated this object. Okay, so name this like a Hack Club, I guess, and export it. So it will take some time and it will have exported. So you got this file here. Okay, wait, I made some mistake. I export in the basic one, I suppose. Export GLTF separate. So you'll get three files: .gltf.bin and this PNG file of textures. So to check online is That was Gldf file. So you can just search Gldf viewer online. So it will give you Gldf viewer. So it will tell you drag Gldf 2.0 file or folder here. So I'm gonna drag all this. Just here. See, it has. See, if you choose any other color, it will be good. So how you can? I think there might be some lag because of Zoom, but if you write on your own computer, you can get this object GLTF model from the Hack Club Git repository. Go to public and your material base color .gltf dot hackclub. Copy this file, clone this repository, copy this file and drag it here. So you will get this object. So when you move, you will see it's very smooth. It's, uh, before, when you object some 3D, when you import some 3D objects in a website, it won't be that much smooth because it will be very heavy and laggy. So the benefit of GLTF is that it is faster loading time and very compact. The size, if you see, will be very small. So if I select and go to properties, you'll see 248 KB is much smaller. It's not even an MB. So bigger file might have bigger MB, but not much. It barely goes up to 15 MBs, I guess, depending on the file. So here you can see if I like want a background, I can use this. You see, it's very good. So like it's very smooth. I'll also show you one game that Anshul showed me. Use it. Okay, so that use Canon. So there's a ping pong game. It's very cool actually. So use Canon.
Anirudh, demo, the
Huh?
demo. Say, yeah, open that link. Yeah,
Demos.
go down.
Okay, yeah.
Yeah,
Fine.
demo ping pong.
So you will get pre-written codes here. Uh, like Anshul showed. And here is a, like Anshul was using the block here. I'm using a badminton or TT bat. So if I click to start, so again, so it's a TT game like used to do in our childhood days, something. Or else if I want to copy this link, copy this link.
Guys, you can act through Zoom. There is a lag because it's actually loading on your GPU. So,
We will
but
share this
when you
link
run it, yeah, yeah, we
on
will
the
share
GitHub
this link. But
repository. Do check it out.
if you will
So
load it on your browser, it won't lag that this much. It's very smooth. It doesn't load your GPU much.
yeah, it's very smooth actually. So there's a possibility of future gaming on the web directly because it's small games, because it's very handy and the size is very low. So if you see, this model cannot be made of the badminton racket or TT racket, cannot be made using simple React coding. So Blender or any other, mostly Blender is used for this kind of task. So now the question becomes, why Blender? Why GLTF? So if you search GLTF, the full form is GL Transform Viewer or Graphics Library Transmission Viewer. Sorry. So GLTF is founded by Kronos Group Inc. So they have so many here, and reference guide is there, validator is there, like is there. And if you don't want to make any GLTF model, so you guys can check for online pre-made GLTF models. So just type GLTF models for free, or if you have a paid model, you can have to. So if you type GLTF models free, you will get many websites like Sketchfab is popular, TurboSquid is popular, and this CG Trader. Any sample models from GitHub also I think you can get. So let me show you some models from this Sketchfab. So GLD model, I prefer free assets, so I'll click on free Gldf assets. So yeah, you can see how many Gldf model are there. Okay, if you are trying something like I'll try this car, click on that, and it is loading the model on his website. So now if I click and rotate, I can rotate on my free will. Anything can be done. This is an HD now. Okay, you can also use cardboard view in VR. My computer doesn't have VR support, so, or you can just download the model and enter the email. You can just download it or log in some ID. I guess I'm sure this is enough. Now transfer back to you.
Okay, guys. So now, as you can see, the GLTF models. We can actually code them. Let me just share my screen.
So now Anshul will use my model that I showed you how to make the Hack Club logo on his website, and it is in GitHub repository. You can download it and use it yourself.
Yeah. So now, what we're going to do, we are going to be importing that GLTF model in our code, and we're going to be animating over it. So here is a empty template. Same thing we have imported, and we have just added canvas here. So the first thing we need to create a component through which we can use our Gldf loader. So we are importing Gldf loader from 3.js 3 and yeah, from to import Gldf model from 3.js, you can't actually do import Gldf from 3. You need to like go deep inside 3 example JSM loaders, then Gldf loader. Same thing is for orbit controls. We will discuss about these two now. So let's just create a component and call it. So logo. I'm just gonna name it logo. And now we need to bring the GLTF model here. So we're going to be using hooks to do that. Okay, so we have a hook here. Now we can't directly call in the GLTF loader. GLTF loader should be in use effects. It's another hook of React. So let's just put use effect here, and use effect will take a function, and we will create a new instance of GLTF loader. And now we can load the Hack Club logo. GLTF, yeah, that should do. Yeah, and we need to update the set model. So what we did, we are storing this whole scene in the model variable. The model variable here. Just give me a second. There's a glitch. Yes, sorry for that. Uh, now we okay. Now we need to return this model in a tag. So return here model, and then a tag called primitive, and we're assigning the object model the scene. Okay, this style of coding is actually Three.js. We aren't using React 3 Fiber much here. The convention is React 3 Fiber, but yeah, this all the lines of code this full is GL React 3, sorry, Three.js. Now we got our component. Now we need to call it inside the canvas. So our canvas needs to be uh, encapsulated within okay, here to here. Yeah. So now we need to bring in the logo. Yes, so you can see a dark shade of logo is here because there's no light, that's why it's happening. So we need to bring in the light. This time I'm increasing the intensity. And yeah, it should be. Yeah, so you got the logo here. Uh, but currently, as you can see, the logo is quite large. So we need to set the camera position, mustache, and then need to declare. Okay, 25 again. Let's just see if it's work or else we will change it. Then field of view we need to set. And yeah, that should do. Yeah, fine. So here above you can see it's a navbar component. So it is in the part of canvas. So if anything goes above from here, it won't be visible. Okay, so we're fine. It's working now. So just writing this, I mean, 5 lines of code, 5 or 6 line of code, we can bring in any GLTF models here. So what else we can do? We can code our own uh, controls. In last webinar, I just brought in orbital controls from Dive, but this time I just want to show you how it actually happens so that you have a general idea how to manipulate the objects around it. Okay, so let's just create a control. And yeah, there will be a return statement. Cool. So we will need a we will need reference variable. So let's call in orbit in camel case. It's React, so using camel case is equivalent to this. And we need to bring in a camera and graphics library GL. It's a DOM element. It actually manipulates a DOM element for controls. So GL from U3. And yeah, further we will just a minute. We will write here uh, controls and add in ref. What was that? Yeah, arbitrary. But it won't work. Uh, we need use frame again. Why we need that is because we need to update the camera's current state on each second. We need to update it because we are moving the camera continuously. It's actually giving us the control, so we need to move the camera and it should be updated. So we need use frame for that. Use frame is the most important thing in React 3 Fiber. It's the best render loop there is. Update. Yeah, that will do. And here we need to add few things. We need to pass some arguments here, and again the mustache dot. No, this will take an array, and array will have camera and gl dot tom element. Yeah. Also, we can add auto rotate. Okay. Um, okay, in Canvas we need to like add all this thing on create. So on created, yeah, on created, it should bring in the function will have a argument gl, an object gl actually, and then we have to gl shadow map dot enabled. We're actually enabling the shadow map equal to true. And yeah, and last time we used a soft shadow function from die. For that, we just needed to like call in the function anywhere in our app. But here we need to declare it within the canvas. I'm just showing you all this because to just show you how hard it gets when we are using Three.js, and we'll go back to that. Okay, three dot DCF soft shadow. No, yeah. Okay. So I haven't called controls yet. What was the name of the control? Uh, okay, there might be something missing here. Let me just check it out. Controls is using 3.3 and update with it there. So this thing, control shift I. Okay, and so there's this thing. If it should give us the control. If you're using this Three.js code, the control stacks in. So you need to be like very cautious about. Oh yeah, I haven't extended the control, so you need to do that actually. What you need to do? There's something called extend. You need to pass in the object orbit controls. Okay, so yeah, and yeah, so we passed auto rotate, so it's rotating. We can control it. In last webinar, it was so easy. We just declared a tag and it was the whole control thing was happening. But this is actually what Three.js happened. This is actually more simplified version of Three.js, what we used to write controls. And in Three.js, if you want to build control, you need to specify it for each scene and you need to update the DOM element each time. So it's too much hectic. And so now I can show you actually how easier it is in Die. I will just comment it out, this part also. And this thing, uncomment the Die. I will comment this. Okay. Yeah. So I can now call orbital controls, and orbital controls already has this property called auto rotate, and also we can specify speed this time. So you can give in the intensity. Yeah. You can increase the intensity. Yeah. So now the object is rotating much faster. So instead of writing all this amount of code, extending orbital controls here, then mapping shadow of GL element, you can just call in one orbit control and it will happen. And for shadow map, like in the last webinar we did, we just need to apply cast shadow on this property and need to specify a plane, and voila, you get a shadow. So you don't need to like do this. So how simple it is, whatever we did in this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and this, let's make it 10. In 10 lines, we can just do it in one tag in a single line. And that too like 3 words, just that. So yeah, I can decrease the speed. And similar to this, you can actually, like I called a Hack Club logo, you can actually bring in any other object, any other object, paste it in public. Yeah, like the white logo on which Anirudh built in this. So you can just put it in the public and load it here. As simple as that. Why we put it in public? Because you can directly access it anywhere through your React app. That's why we're doing. Otherwise, you can just put it in your separate asset folder and call it from there. So yeah, this was all about Gldf loaders and orbit controls. So I guess, yeah, this is it for our session. You can explore more. You can toggle around with Three.js documentation. And yeah, this organization, PM and DRS, they have everything related to building 3D objects, 3D modeling over React. They have even AR, VR, they have physics engine, they have, and it's much more simpler. You just, like I showed, it reduced the 10 lines of code to one single tag. They have also a GUI. I guess I showed in the last session. Let me just go here. Yeah, they have some awesome examples also, and it's on Sandbox, so you can actually see their code. And it's much simpler code. They are actually importing various Gldf models and animating them. Like Anirudh told you, like there are edges over this Gldf model here, edges. So you can actually animate over them. It would be complex. It will require so many a different set of code. You need to specify everything. You need to make different meshes. So that's why it's I'm not getting there. It will be a much larger. It will require like a series of session on its own. So but you can animate them. So yeah, so here it let me show you. Yeah, React 3 GUI. So whatever we are doing in code, you can just do it in with the GUI. There's that. There's XR, React 3 XR. It's for AR VR controllers. So whatever we built, you can just import that same thing in AR or VR. Okay, so even in augmented reality, you can import in software. So if it's real world, it can interact with also. So you can try all those things. It will require AR VR controller. Okay. And yeah, all the documentation are very proper, like how to code in, how to get started, everything, all the APIs and all. Yeah, you guys should check it out. In the Canon JS we discussed, it's there. Post-processing effects, all the effects are already there, and die. This is a very important library. Like I showed, this simplified the whole code with one tag. And also, yeah, die actually has a Gldf loader. We won't need to write this much amount of code also. We just need to write one line and the file will be loaded. Uh, Let me go to GL loaders. Yeah, yeah, here it is. Uh, Let me open its npm. The npm.js.com package. die. It has this documentation, like how to use the code snippets and all. It already has. So if I go to loaders, Gldf, yeah. So you just need to use this. This is also hook. See, hook is a very important thing. They changed the entire Three.js coding on hooks. Like they are using only hooks now. So you just need to use the hook, provide URL, set it true, and it will be loaded. Your and you need to load binaries here. We loaded .gltf, but we also if we get binaries .gltf, we get .bin. So it's the binary. You need to load that, and it will be done. So it's much more simpler. Yeah, and yeah, FBLX loader. There's something called FBLX. You can load that. If you want to load textures, there's a texture loader, and there are a few other things. Like we used orbit controls. There are very different types of control: fly control, map control. Okay, and abstraction shaders are there for shadows and all. You can apply these. There's the miscellaneous properties are also there. So you can just toggle around this and you can build something really awesome. And the ecosystem around this is quite growing in last few years. And even in the JS convention, the JS Nation, they had a separate session for React 3 Fiber, where the creator of React 3 Fiber, Paul Henschel, came himself and uh, took the webinar. He explained all the WebGL part also, everything. So you can just try it out. I guess that's it for the session. I will stop the screen sharing. So I guess, yeah, that's it.
Thank you, Anshul, for the wonderful session. I guess we can wrap up now. So, guys, there's a Hacktoberfest starting from 1st October, and we have our events on 4th. We will be issuing out the brochures very soon. So please join us. Join us.
Yeah, for we are opening our own repository, so you can find issues and open PR and get grab some swags apart from the swag provided by Hacktoberfest. So yeah, and there will be some very informative webinars from very known people. So just stay updated. We will update you about everything. Thank you.